This graph shows how much moisture some gas or air can contain. On the x-axis, we have the psi, gas pressure. So starting from 0 to all the way to 280 psi. On the y-axis, this is the amount of moisture contained every 1000 cubic foot. So 1000 cubic foot, how much moisture some air can contain. So let's say this is 1000 feet cube, and in 1000 feet cube how much moisture this thing can contain. Also you have this for different temperature. Think about this at 120 degree Fahrenheit, at for example this is 100 psi. So at 100 psi, 120 degree Fahrenheit, the maximum moisture a 1000 feet cube gas or air can contain is about 0.55. It's between 0.5 and 0.6, so I would say it's 0.55, like that. So that's how we determine that's how we read this table. Now these numbers are basically this 6.3, this is in 0 psi. This thing kind of extend this way, but we cannot just keep doing it. It's too much big figure. So only these values are given for 0 psi. So at 0 psi, 130 degree Fahrenheit gas can contain up to 6.34 pounds of moisture every 1000 feet cube. So by using these graphs, we can determine if we reduce the temperature from, for example, say 120 to we reduce up to 80 degree Fahrenheit, and then the psi we keep it constant at 120 psi. So the amount of moisture removed would be this, and then just about this. So this point we can say 0.48, and then this point we can say it's about here, so 0.18. So the amount of moisture removed if we reduce the temperature from 120 to 80 degree Fahrenheit at 20 psi, then the amount of moisture will be removed is 3 feet cube for every 1000 feet cube of gas or air. That's how we read this table.